Hi, my name is Jun Chu. I'm a professor of Pharmaceutical Sciences Department of SUNY Buffalo. And also, I'm the director of Pharmaceutical Analysis Core in the New York Center of Excellence in Life Sciences and Informatics. So what we are focusing on the protein bioanalysis using LCMS. So both global quantification, we also call it the proteomics, and the targeted quantification. So our focus is high quality quantification and develop new method that is more sensitive, more selective, and more accurate to achieve this goal. So far, our lab has been using the thermoscientific TSQ Altis for several years in protein quantification. We really love it. It shows high sensitivity with high throughput, making it an excellent machine for targeted quantification of protein drugs and biomarkers. In the past year, we acquired the thermoscientific FAIMS Pro, which has enabled my team to push the boundaries of sensitivity and selectivity for protein analysis to yet another level. My lab is working on protein bioanalysis and pharmaceutical analysis. So in the past decade, the landscape of pharmaceutical analysis has changed drastically. So we deal with small molecule all the time, but right now the focus has shifted to protein drugs, especially the antibody-based drugs. And also people found out that the biomarker analysis is really important. So there's data showing that clinical trial with a good biomarker is much less likely to fail than the one without. We are very excited about the introduction of two new instruments, thermoscientific TSQ Altis Plus and the FAIMS Pro Dual. In our most recent studies and evaluations, we found those new instruments brought a new level of productivity to our labs. The high-resolution SRM functionality combined with improved mass stability on the Altis Plus enabled not only the ultimate selectivity and sensitivity, but also maximize throughput, reducing sample preparation efforts, and therefore greatly boosting the productivity. The thermoscientific FAIMS Pro Dual combined with the new CV optimization tool give us amazing sensitivity and also the necessary flexibility and utility for method developments. So I would say that just like the invention of a jet plane overcome the sound barrier, I think the combination of Altis and FAIMS technology does break the barrier of sensitivity for protein drug analysis. Also, I would think those technology are really good to have in a clinical and pharmaceutical analysis lab if you want to have the productivity at the same time high sensitivity and selectivity. Usually the throughput, sensitivity, selectivity don't go together when you talk about protein drug analysis by LCMS. I think using this combination of technology, this can be a reality. If you develop a protein drug, you want to know how it distributes in the system and what is its kinetics. So that requires sensitive, selective, and accurate quantification in the system. So my lab is one of the leading labs in the field doing the LCMS-based protein drug and biomarker analysis. So we think the sensitivity and selectivity is a key to achieve a reliable quantification. In the pharmaceutical world and also in the clinical world as well, accurate quantification with good selectivity is important. More accurate, sensitive, and selective technology is what we are chasing after over the years. So those are very important because if you want to evaluate a drug, you have to have really accurate analysis, and you have to make sure what you are seeing is really your target, not anything else. Otherwise, the consequence can be substantial.